Hi everyone, this is a demonstration. It's a homework help demonstration for question 4 on our modifying loans. Oh, sorry about that, getting some noises. Okay, so this is exercise 7.07 and it's question 4. Now remember, it's a homework question and it's open help. You're allowed to watch the video to get help, but I'd encourage you to watch just a little bit, and then if you get the idea of what's going on, pause and do the rest of the question for yourself. So let's begin. We've got a situation where a person borrows $25,000. So that's the principal, A is the amount borrowed, at 6.4% per annum. Now, it's monthly rests, and we write our percentage as a decimal and we divide by 12 because it's monthly payments. Now, I wanted particularly here to demonstrate the use of the Casio calculator. So there's my interest rate, and we will divide this by 12 equals, now we don't usually write them as fractions, so there's a number. Wow, what a number. And I can do crazy things like that, which is annoying, but I suppose all that really matters, oh, that's what I wanted, as a decimal. So I would not really want to be writing down 0.005 blah 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 on my page, but I don't want to round off too much. So if I round off too much in my calculations, I'm going to get errors. Now this is what I need to do. Do you see these little letters A, B, C, D, E, F in red here? Those are places that you can store in the calculator memory. And you need to press the STO, so it's Shift and then this key, and then I press, say, this one for A. And you notice it's gone answer into A. So I can just clear that now. And to get that back, I just press recall A. There it is. That's my answer that I had a moment ago. Recall A will give me the answer. So I don't need to go writing that all down on my pad. It's now stored inside my calculator for future use. So that's the first bit. Now remember, we have R equals 1 plus I. So 1 plus that number will be 1.005 with all those extra 3's running on. Using the calculator now, I go 1 plus. Now if I want to use the letter A in a formula, I have to use this alpha key before I press. So alpha A, just to type the letter. That will get the number from memory. When I press equals, this is my new number. Putting it like this, that's what I need to see, 1.005. Sorry, I made the calculator go away then. Now that's really the thing that I need for future reference. So I'm going to store that one. Store, and I'll put it into B. So it's there, I can press all clear. If I go alpha B, then I don't see the answer, but it's ready to have. If I press equals, it gives me the answer. If I just go recall B, it gives me the answer straight up. So there's a very handy little feature. Now let's do the first part of the question. If you are happy with what's going on now, you could pause the video and take the rest of this question for yourself. The other thing I need to make a note of is that our loan here in the question is over 7 years, and it's monthly rests, so 12 months in a year would be 84 rests, meaning 84 payments are due to pay this loan back. And our first question is, what is the monthly payment? So the monthly payment is given by, let's check our formula, this one here, AR to the N, R minus 1 over R to the N minus 1. That's our formula. And all of these things are what we wrote down to start with. 25,000, 1.005 to the power 84, 1.005 minus 1, 1.005 to the power 84 minus 1. Now, let's have a look at how to use the calculator to do that. So I need a fraction. I need 25,000 multiplied by, now this number here, the 1.005, that's the one that we had stored in memory B. And by pressing the letter B there, I will not have any rounding off errors occur. That's to the power of 84. Now I need a bracket. That's letter B again, minus 1. Close off the brackets. Now I have letter B again. You can see how quick this is compared to retyping, to the power 84 minus 1. Now fingers crossed, there's our answer. $370.03. So our repayment is $370.03 every month. Now you probably remember that the second formula involves the use of letter Q, the repayment. It's probably worth storing that before we lose it. Shift, store, C. So if I recall C to check, there it is. It's there. It's going to be remembered for me. Now, I'm starting to lose track a little bit of which is stored where. I was stored, this number was stored in memory A, this was stored in memory B, and this one now is stored in memory C. I'm just writing a little note there for myself so I don't forget. Now let's move on. If you want to pause at this stage and take the rest of the question for yourself, be my guest. Part B said, how much does he repay in total? Total repaid. Well, there's no formula for this one. This one is a little bit of mathematical common sense. If you pay that much money every month and you have 84 payments, this is a straight out multiplication question. So here I go, 84 multiplied by, now this is why I needed to store the repayment in C. So alpha C, we'll recall that number. There it is, $31,082.25. $31,082.25. Part C. How much interest does Oliver repay over the life of the loan? Well, the total interest, again, there isn't a formula for this one. This is a bit of mathematical common sense. If you have paid the bank $31,082.25, you originally borrowed $25,000. Well, how much more have you given them back than what they loaned you? It's a subtraction. So we subtract the original $25,000 principal. I probably could have done that one without a calculator. $6,082.25. That's how the banks make their money. They loan people a lump sum of money. The people have to pay that back plus interest. In this case, Oliver paid $6,082 worth of interest. Now part D, again, if you want to pause and continue on your own, be my guest, but this is open help homework, so I don't mind if you keep going if you need the help. So the part D, this is where things start to go a bit awry. After 3 years, the interest rate changed. And then we have to figure out, the new interest rate was 7.9%. And the new, let's see, the new interest repayment, well, how much is the new repayment, they say? Well, this is where we have to calculate the balance of the loan after the 3-year time period. Now the formula, if we were to look back at the top, would be Bn equals A times R to the power n minus Q. Let's go back and check. It's r to the n minus 1 over r minus 1. R to the n minus 1 over r minus 1. Now a lot of these numbers will be numbers we've already seen before, but importantly at this point it's only 3 years that the loan has been running, not the full 7 years. So we are really talking about the balance after 36 payments. Please don't put 3 there. Remember, the number n is the number of rests or the number of payments. Our original principal was $25,000. R was the number 1.005 to the power 36. Our Q value was $370.03. Again, R is 1.005 with a lot more decimals. Don't forget it's stored in the calculator safely. Minus 1, and just that part is divided by 1.005 minus 1. Now this is absolutely going to be something I need to get the calculator going for here. So I don't really think I need that number. I didn't save that one. Now let's do the calculation. 25,000 multiplied by, now remember this number 1.005 was stored in memory B, and because I'm typing it in a big formula I need to go alpha and then that key to just get the B there, to the power of 36 minus, now I'll make a fraction, the repayment amount was stored in memory C. Open a bracket. Oh, that's the number stored in memory B to the power of 36 minus 1. Close the bracket, down to the denominator, and again that's the number stored in B. No powers on it this time, minus 1. Now, after 3 years, our friend would still owe $15,633.49. So let's write that down here. The balance of the loan is still $15,633.49. Now I'm definitely going to store that number because I'm very, very sure I'll need that one again. So remember, shift, store, and now I'm up to memory D. So I'll just check that it's there by going recall D. Yes, that's safe. There it is. And I'll make a little note to myself here on my working that that's stored in memory D. These little letters that I'm writing are just so I don't forget which numbers are stored where. Now part D of this question said, what's the new loan repayment? Well, this is more or less a new loan. It's not really a new loan, but I'm going to think of it like the first loan stopped after 3 years and then a new loan started with this as the principal. So let's have to write this down. The principal is $15,633.49. The interest rate has now gone up to 7.9% per annum. And that's what happens with variable rate loans. So if you sign up for a variable rate loan, the interest rate can go up or perhaps it can go down as the loan progresses. So I'll be calculating this one. As a decimal, it's 0.006. Now I'm absolutely sure I will need this in the future, so I will store that one and I'm up to E. It's lucky I've got so many different memories here. Let's just check by recall E. Yes, there it is. That's the number. So to write that on the page, 0.006, and then there's 58333, but I'm not going to go crazy with writing the whole thing because the calculator will remember it for me. Remember, r equals 1 plus I, so that will be 1.006. Now don't forget to actually calculate that out on the calculator. Plus 1, double check that it's what we think it is, yes. Now let's store that one. Now I had originally stored that one in E, but this is the more important one, so I think I'll just store that in E, and it just goes straight over the top. The previous number is gone, it's forgotten, the new number is remembered. So if you're running out of memories, that's okay. Sorry, this is the one which is E. That's nearly a mistake there. Okie doke. So now let's see what we're doing. We've got that, we've got that, we've got that. What about N? Well, the original loan was for 7 years. The interest rate changed after 3 years. There are still 4 years remaining on the original loan. And of course, it's still monthly payments. So we have 48 rests. Now, we can calculate the new repayment. Our formula for the repayment is A times r to the power n. Let's just go back and double check that we don't mix it up. This is the one where r to the n is in the denominator. See how the r to the n swaps in these two? It's annoying, isn't it? So r minus 1 over r to the n minus 1. R minus 1 over r to the n minus 1. Now what's A? That's $15,633.49. What's R? R is this new number, 1.006. Now it's to the power of 48, because there are 48 payments remaining in the original life of the loan. 1.006 minus 1 over 1.006 to the power of 48 minus 1. My calculator is going to get a good workout here. Now remember that this 1.006 number is stored in E and the 15,000 is in D. Here comes the, where's my calculator gone? Oh, I lost my calculator. Here it is. So let's see how we go here. I'll need a fraction. That first number was D, multiplied by that next number was E. And that's the one where we need a power of 48. Now a bracket, that is number E again, or memory E, minus 1. Now down here it'll be E to the power of 48 minus 1. Our new repayment is $380.93. So I'm going to store that one. I'm sure I'll need it. And I'm up to F now. I've actually used all the memories for this thing. So I'll write that down before I lose it. It is $380.93 is the new repayment for the last 4 years of the loan. Part E. Well, you can pause now and continue on by yourself if you'd like. How much more does it cost Oliver to pay out the loan due to the increase in interest rate? So let's work this out. So the original loan, from this point onwards, he would have had 4 years worth of 12 payments, and the original payments were $370.03. The new conditions with the interest rate rise, he's got 4 years worth of 12 payments, and the new payments are $380.93. So he would have made this size payment for 4 years if the interest rate didn't go up. But the interest rate did go up, he now has to make this payment. So let's calculate these two answers. So that's my previous number that's already there. If I just go multiply by 48, I get 18,248. Let me write this. $18,284.43. That was with the interest rate rise. Now, where did I store the 370? I know I stored it. There it is. 370 was stored in memory C. So if I come back to my calculator here, this one will be 48 times C, 17,000. Let me write that. The original loan, he would have repaid $17,761.29. Now these two are just the last 4 years of the loan. The first 3 years of the loan were the same, so there's no point in worrying about them. The extra is only going to be due to this increased interest in the last 4 years. And the question was how much more? So the additional interest. Now again, there's no formula sheet for this one. This is using our mathematical common sense. How much more was the bigger number? So this is a difference. We need 18,284 and 43 cents. Subtract 17,761 and 29 cents. Let's just figure that out. What is it? 18,284 and 43. Subtract 17,761 and 29. This gives me $523.14. $523.14 is the additional interest that was paid in the last 4 years because of that interest rate rise. So that was a really long question. If you've stayed with me all the way through, well done. If you have only watched a little bit and paused and done the rest yourself, you won't be hearing me say this, but even better. So that's great. I will be seeing you in class on Friday. Thanks for watching.